Okay, you have to keep with our topic. It's a long one. And we're still dealing with these rational exponents and radicals. So this is E. Let me get that down for you. Um, we've got rational exponents and radicals, and this is E. Okay. So the last thing that we did, and let me repeat it. I think it's worthwhile. The last thing we did that was actually number 13. So it was the 13 on the previous video, and it was the fifth root of x to the 27. So here's how you deal with something like this. Fifth root is the key. Whatever it says over there in the root area, that's our key. So we need to be something, to get a perfect fifth root, we need something divisible by 5. So what is the largest number beneath 27 which is divisible by 5? The answer to that is 25 is divisible by 5. What's the leftover? You can't just break 27 down into a piece without the missing piece. The missing piece is x to the second. Also the fifth root. I forgot to put the fifth root, and I forgot to put the fifth root. Very important. Fifth root, fifth root. X to the 2. Why is that true? x25 times x2 is x27. Gets back to the beginning. We're allowed to break x27 into two pieces. What does that accomplish? The 25 divided by 5 turns into x fifth. No more radical there. That's the whole point. And we have a leftover, which is fine. There's nothing we can do about the leftover, but we got as much as we could from beneath the radical. That was the answer to 13. Now we go to the next level. Problem number 14. Problem number 14 looks like this. It's a little bit more complicated. What if you've got, here's the fourth root, not a fifth root, but a fourth root, 32, x9, so it's got a number in it, it's got an x in it, and it's got a y6. Okay. I got to break this down into two pieces. I got to put all the perfect fourth roots on the left and all the leftovers on the right-hand side. Okay, now 32. Can I break that into two pieces? And one of them is is perfectly a fourth root. We'll get ourselves a regular number with a fourth root. The answer is yes. 16. I'll be able to take the fourth root of 16, so put 16 on the left and put 2, the leftover on the right. 16 times 2 is 32. That's the leftover. What about x9? Divisible by 4, right? x9, what's the highest number beneath x9 is divisible by 4? Answer, x8. What's the leftover? X. What's the highest number of y6 divisible by 4? 4 itself. So put y4 over here. And the leftover, to get back to y6, is y2. My leftover for this one with x, was going to be back for a minute, is x to the 8 was the highest number divisible by 4, and x to the 1 is the leftover. 8 plus 1 gets us back to 9. So all the perfect fourth roots are over here, and the leftovers are over here. Let's get the fourth roots out of there. Fourth root of 16 is 2. The fourth root of x8 divided by 8 divided by 4 is x squared. The fourth root, y divided by 4, 4 divided by 4 divided by 4 is 1, so it's y to the 1. Don't bother writing the 1, it's 1. That's beneath the radical. That's good. We got as much out of the radical as we could. This way I can't do anything about, I can't do anything about, I can't do anything about. There's the final answer. We have simplified. Okay. Now we go on to more about this stuff. It just looks a little bit, some of this stuff looks a little bit different than the others. But let me give you over here, let me try to use my space wisely here. And let me give you over here two rules that we really know already, but let me show them to you again. If you have the square root of 3/4, we've talked about this before, you can change this into the square root of 3 over the square root of 4. Perfectly legitimate, totally allowed to instead of have one big radical, I can make it two radicals, one for the numerator, one for the denominator. No matter what it said in here, 5, 7, 11, doesn't matter. What if I have the square root of 3/4, and for some reason it's going to be convenient to break it into, I have the square root of 3/4 itself, 3 over square root of 3 over square root of 4, and it's convenient to actually put it into 1. So it works both ways. Of course, I can put it into just one radical. It goes this way, and it goes the other way as well. You can either one to your advantage you can use. Okay, so having said that, I'm ready to do two problems that I can show you why that can be helpful. All right, here's problem 1. Problem 1 is I've got the square root of x3 over 9. So at first it looks like, what am I going to do with that? What's that going to, how am I going to simplify that? So here's the root to getting there. No pun intended. The square root of x cubed, put in its own square root, give x cubed its own square root, and give the number 9 its own square root. Okay, now let's go to scrap paper. How do we break down the square root of x to the cube? We've had this before. You put it into two pieces. The square root of x squared is the number that's divisible by 2, the largest number divisible by 2 beneath 3. And the leftover was just plain x to the 1 power. So this I can change into x squared. I'm sorry, square root of x is just plain x. The square root of x squared is just plain x. And the leftover is the square root of x. So this, I went to my scrap paper. I broke it down into two pieces. The square root of x squared is x, and the square root of x is something I can't do anything about. But at least I got something simplified out of that radical. What about the square root of 9? It's 3. This problem is over. So there was an advantage of taking one big square root and giving each the numerator its own square root and the denominator its own square root, and we got this problem solved that way. Okay, here's another situation where these rules that I set up over here on the right-hand side come into handy. Number 2, what if you have the cube root, sorry about that, cube root, 3x to the 7, 3x7y, over the cube root, here we go, cube root of 81xy4. 81xy4. Now, watch this. If we put them under the whole thing into one cube root, we'll have something that looks like this. The cube root of 3x7y over 81xy4. Okay, bear with me. 3 over 81, my next step is, it's going to stay cube root. 3 over 81, both are divisible by 3, so on top is a 1, and on the bottom is a 27. 3 divided by 3 is 1, and 81 divided by 3 is 27. I don't need the 1 on top. x7 over x, we've seen this before. 7 minus 1 is 6, so x6 wins on top. And y over y3, we've got y over, what was this? y4, not y3, y4. y over y4 turns it, there was a 4 here. I apologize. y4. The y over y4, the 4 wins on the bottom, so it turns into y cubed. Okay, sorry about that. This is a 4, right? The problem started out as a 4. I was supposed to have written a 4 here. I corrected it. It's a 4 now. And this turns into, when you do the y and the y4 together, 4 minus 1 is 3, so y3 wins out over here. Okay, now let's go back to putting them in their own pieces. The cube, after we finish this, we can now, let's put it back into cube root. Let me move the paper up. I'm sorry, 1 second. There we go. We got we got more space. Hold on. So I'm doing problem number 2. Let me cordon it off. And now I'm going to turn this into the cube root of x6. I'm going to turn it back to what it used to be before, over the cube root, because I simplified everything, over the cube root of 27y cubed. What's the cube root of x6? 6 divided by 3 is 2, so it's x squared. What's the cube root of 27? It's 3. 3 times 3 times 3 is 27. And what's the cube root of y3? Y itself. And it's all done. It's all finished, and all the radicals have been cleaned up. This one actually embedded in the answer to the problem actually turns out to be that we don't even have any radicals left at the end of the day. That's how well this thing turned out for us. Okay, we're going to have to end this video. We've got no more paper. We're going to go on. We got still a little bit more to go. I think we got one more video to go about this topic. But this one is over.